Hello everybody and welcome back to Business Statistics online at Frederick Community College. In this video, I will talk to you about hypothesis testing on two samples. So this video assumes you know the terminology, you read the textbook, and you're comfortable with the notation. But as you read through the book, you probably realized that the computations are pretty messy. That is why I have this file created for you guys that you can use as you solve problems on homework, okay? So you still need to know the notation, and you still need to know the basic ideas of hypothesis testing, but the computations are not as important. All I want you to know is how to come up with the correct conclusion. So let's go ahead and do some problems on your homework, and we're gonna go through two problems. First one is problem 1 on module 3 section 10.2, and it just gives you statistics for two samples, and it doesn't give you any context, but that's okay. So let's see what we need to make sure that is satisfied. We must have independent samples. The samples need to be large enough, or both populations need to be normally distributed. So n needs to be greater than or equal to 30 for both samples. And in this case, we'll talk about the scenario where we don't know the population variances and they're not equal. The textbook does cover the situation when the population variances are equal. We're not responsible for covering this material, okay? And you will see that all of your problems will assume that the population variances are not the same. So here's the statement right here. Okay, so let's go ahead and see how we solve this problem. Okay, I want to see if there is no difference between the means for these two populations, right? Based on these two samples. Okay, I want to double check my assumptions. Okay, population variances are not equal. Populations are normally distributed. I'm good to go. Let's just go ahead and do some computations. So, alpha level is 0.01. And now I carefully plug in my values for N1. That would be 12. X bar 1, so that's 115.8. And sample standard deviation from the first sample is 25.5. Okay, we'll keep going. 21 here, 122, 14.1. Okay, and you see that the numbers are changing. So are these numbers different? 115.8 and 122, yes, they are different. Are they different enough? That is the question, okay? All right, let's go ahead and answer these parts. Calculate the appropriate test statistic and interpret the result. Okay, this would be this value right here. And if you try to match this is actually the formula from your textbook. I just typed it in Excel format. Okay, so negative 0.78. Okay, good so far. The critical values, let's go back to our file here. This is a two-tailed test, so I'm looking at these critical values right here. They want us to do two decimal places, so this would be plus or minus 2.98, okay? Negative 2.98 and positive 2.98. Okay. Where is this value right here? It is between these two, right? So because the test statistic falls within the critical values, we do not reject the null hypothesis. Good so far. So this would have been done if that's only if you were asked to do this one method, okay? And on the test, I would just ask you to do one method, and you get to choose which one. Well, let's say they wanted to test if we know how to use the p-value method, and the answer is yes, we do. We'll look at the p-value for two-tailed test, okay? 0.45, That's a large p-value. And what is the conclusion? The p-value, we compare that value to alpha level. It's a lot bigger than 0.01, so it is not less than the significance level. So we do not reject the null hypothesis. The answer here is C. What? Okay, the p-value is not less. Okay, the p-value is not less. We do not reject. No, I didn't read it right. So it is not less than significant levels. We do not reject the null hypothesis. Yes, that is correct. Okay, so here's how you would solve this problem. Again, I want to emphasize this part right here. We need to check that our assumptions are satisfied because these samples are actually small. But because the populations are normally distributed, we're good to go here. Okay, let's solve a problem that's actually a word problem. So I want to do problem 4. Let's see what we have going on here. Suppose a student organization at a university collected data for a study involving class sizes from different departments. So we have business department and engineering. They tell us this sample mean size, okay, standard deviation and sample size. Okay, use this data to complete parts A through C. Okay, and what they want us to do is to determine if the average class size differs between the two departments. Okay, again, here's another assumption that's important. The population variances for the number of students per class are not equal. Okay, so we can go ahead and use our two-sample t-test. Let's see, alpha level, 0.10. The first sample was 14 students, no, 14 classes, not students, that's 14 classes. Sample mean size, 38.1. Sample standard deviation, 10.3. Second class, 16. 32.1 was the sample mean, and 13.4 is the standard deviation. Okay, so that's done, but let's actually answer some of the questions here. Determine the null and alternative hypothesis for this test. Okay, the null hypothesis says that there is no difference. The alternative hypothesis says yes, there is. Okay, are these two numbers different? Yes. Are they different enough? Well, that's what our job is to find out. Okay, test statistic. Let's go back to our Excel file. Test statistic is right here. They want us to do 2 decimal places, so that's 1.38. Okay, critical values. Again, we're looking at two-tailed critical values, right? So that would be negative 1.7 and positive 1.7. Good to go so far. Again, what happens here? This value, 1.38, is between these two. So it does fall within the critical values. We do not reject the null hypothesis. It doesn't fall into the critical region, right? So the average business class size is not different from the average engineering class size. Check the answer. This looks good. P-value. Okay, let's take a look. We need two-tailed test p-value, and they want us 2 decimal places, so that would be 0.18. 0.18. Okay. Why do you not like that? Let's go check. 0.1, 3 decimal places. Okay, so 0.78. All right. I'm having a hard time reading today. That's okay. That is correct. And now let's make sure I don't make the mistake that I've done before. So since p-value is bigger than alpha level, which is 0.10, it's bigger. So equal or greater, yes. We do not reject it. So since p-value is equal to or greater than the significance level, we do not reject the null hypothesis. Notice that this should match this one right here. Whatever method you're using, the conclusion should still be the same, right? Let's check the answer. Good to go. Oh, last one. What assumptions need to be made in order to perform this procedure? Okay. Samples are 14 and 16 for sizes. We need to make sure that both populations are normally distributed. Okay. So let's see. Not B. If both sample sizes are not each at least 30, then one must assume that the underlying populations are normally distributed. Yes, so that would be D. Check the answer, and that is correct. Okay. All right. So this is two problems that you have. One in context with the context of what sample size, not sample size, class size, and on average they're not different, right? And then you have a couple of different problems here in this homework assignment. So they'll all pretty much solve the same method, and you will see that all of them are saying that the variances are not equal. Okay, when the variances are equal, there's a slightly different method, and you guys are not responsible for knowing this method right here. Okay, so use this file to solve your homework problems and your weekly activities. Okay, thank you for watching.